Good morning, everyone. Our project is titled Early Detection of Stroke Risk using a feedforward supervised neural network with backpropagation algorithm. Stroke is a major cause of death and long-term disability globally. Therefore, identifying people at high risk for stroke early will allow for the prevention of serious medical issues. In this project, we aim to create a deep learning algorithm to detect stroke risk in patients, which will allow making informed decisions about healthcare. The feedforward supervised neural network will be used along with the backpropagation algorithm to make predictions for stroke occurrence. In the process, a stroke prediction model will be created based on the stroke prediction dataset. In this project, there are three problem statements. Firstly, current methods may not accurately predict stroke risk because they cannot handle complex health data effectively. Second, healthcare providers need a reliable way to identify people who are at risk of stroke. Third, there is a need for a machine learning model that can predict stroke risk using patient data. The objective for the project is to develop a feedforward neural network model using the backpropagation algorithm for stroke prediction. Second, to prepare and process the stroke dataset before training the model. And the last objective for this project is to evaluate the performance of the model in predicting stroke risk accurately.
Okay, Assalamualaikum, my name is Marwa and my metric number is B0324110000. Next, I will explain the deep learning using Python and the important deep learning functions used in our project. Deep learning is a branch of machine learning that allows computers to learn from patterns from data automatically, similar to how the human brain works. Unlike traditional machine learning, deep learning can learn features directly from data without requiring manual programming. In our project, deep learning is used to predict whether a patient is at risk of stroke based on health information such as age, BMI, glucose level, and smoking status. Okay, next, Python is widely used for deep learning because it is simple, easy to understand, and provides powerful libraries such as TensorFlow and Keras. These libraries help developers build neural network models more efficiently without trying or writing complex mathematical equations. Our model uses several important deep learning functions. First is the value excavation function is used in the hidden layers. It converts negative values to zero, which helps the model learn faster and improves performance. Next, the sigmoid excavation function is used in the output layer because it produces values between 0 and 1, representing the probability of stroke occurrence. The binary cross-entropy loss function is used to measure the difference between predicted results and actual results. A lower loss value indicates better model performance. The model is then improved using backpropagation, which updates the network's weight based on prediction errors. In addition, the Adam optimizer helps the model learn more efficiently and reach better accuracy. And finally, we evaluate the model using metrics such as accuracy, precision, and recall to determine how well the model predicts strokes risk.
Now I will talk about raw data description. The raw data that we use as a dataset for our project is healthcare dataset stroke-data.csv. We use this dataset to predict whether a patient is likely to suffer a stroke based on demographic and medical information. This dataset contains 5,110 patient healthcare records with 12 variables, which are ID, gender, age, hypertension, heart disease, ever married, work type, residence type, average glucose level, BMI, smoking status, and stroke. For hypertension, heart disease, and stroke variables, the dataset use 1 and 0 to represent the data value. So, if the patients have the health conditions, the data is represented as 1, and if the patients do not have it, the data is represented as 0. Then, I will talk about the step-by-step on how to download the dataset. Step 1. Open the Kaggle website. Step 2. Create a Kaggle account. Step 3. Search for stroke dataset. Step 4. Download the healthcare dataset stroke data.csv dataset as a zip file. Step 5. Extract the zip file. Step 6. Place the healthcare dataset stroke data.csv dataset in the project folder. For flowchart, this flowchart illustrates the workflow of our system. We begin by loading the stroke dataset and pre-processing the data by handling missing BMI values and encoding categorical features. Next, we apply feature scaling using standard scaler to normalize the data. A feedforward neural network is then developed and trained using the backpropagation algorithm. After training, the model is evaluated through accuracy, confusion matrix, and classification report matrix. The trained model is then used to predict stroke risk. And finally, the results are analyzed to derive meaningful findings and conclusions.
For step-by-step learning, first we need to load the dataset. This dataset we actually got from the Kaggle, the healthcare dataset from data. And then we process the dataset. And then we scanning the dataset using standard scanner. After the data is clean, we will using the Feedforward neural development, which is backpropagation algorithm to extract and to get the output, the asset that we want. And then we will use the model training to compile the neural network. So, for analysis of part, actually our system is really successful. And then the training accuracy increased steadily while the loss value increased throughout the training process, and it's showing and convergence of the neural network. Based on our system, the overall accuracy is 74%, which is the model performs reasonably well. In addition, the model successfully identifies 71% of actual stroke cases. But as you can see from the coding, both training loss and validation loss decrease steadily over 30 epochs. And this indicates the backpropagation algorithm successfully updated weights to minimize prediction errors. But however, there is a weakness of our model, which is many false positives, and patients predicted to have stroke but actually don't. This means 85% of stroke predictions are incorrect. Also, the training accuracy, which is 85 to 90% is higher than validation accuracy.
Data analysis with DL models and their output. We built a neural network with 11 input features passing through 2 hidden layers with 64 and 32 neurons respectively. The models was trained for 30 epochs and the loss function decreased from 0.72 to 0.12 and 83% improvement. Results show 74% accuracy and 71% recall, which means we correctly identify most stroke cases. Specificity is 77% and ROC/AUC is 0.82, indicating good discrimination ability. However, precision is only 15%, meaning we have many false positives. We also observe overfitting both. Training accuracy reached 88%, but validation accuracy was only 74%. Explanation on finding figures and result. The model's main strength is 71% recall. We catch more stroke cases. The weakness is 15% precision. 87% of our alerts are false alarm. We have 4 improvement strategies. First, address class imbalance using weight loss function to increase precision to 40 to 50%. Second, reduce overfitting by increasing dropout to 0.3 to 0.4 and adding
L1/L2 regularization. Third, adjust the threshold from 0.5 to 0.4 to increase recall to 78%. 4. Apply feature engineering to improve accuracy to 78 to 80%.
In conclusion, our project successfully developed a feedforward supervised neural network using the backpropagation algorithm for stroke risk prediction. We used the Kager stroke prediction dataset containing health factors such as age, hypertension, heart disease, urine level, BMI, and smoking status. We also apply data preprocessing technique including missing value handling, categorical data encoding, and feature scaling. The model achieved an overall accuracy of 74% and correctly identified 71% of actual stroke cases. The decreasing training and validation rules show that the model learned effectively during the training process. Although some false positive predictions and slight overfitting were observed, the model still demonstrates promising performance. The proposed model demonstrates the potential of deep learning in healthcare and can support healthcare providers in early stroke risk assessment and intervention.
Can somebody explain how the feedforward neural work?
A feedforward neural network works by passing input data through layers of neurons in one direction. Each neuron computes a weight sum of its input at a base and applies an activation function to produce an output. The network first performs feedforward propagation to generate a prediction, then calculate the error by comparing the prediction with the actual target value using a loss function.
That's all of our presentation. Thank you for the attention.